All right, so we're going to call this right triangle proof day 1. It's actually from chapter 14, don't be hush, but we're not going to apply it to each of the sections right yet. Okay, so just call this right triangle proof day 1. Okay, so based on what we just figured out with SOHCAHTOA and the ratios that exist with right triangles, we can now use that to help us solve the missing parts in triangles. All right, so it says find the missing side length and then find the values of all 3 trigonometric functions of theta. All right, so how can I find the missing side length? Yep, you're right. The diagram here on. All right, and that is a squared plus c squared equals c squared. And remember, c is always the hypotenuse with Pythagorean theorem. So let's plug in what we've got. We've got h squared plus 15 squared equals c squared. So 64 plus 225 is equal to c squared. And what is that? 289? And then how do I solve for c? Right. Then we get c equals what? 17. All right, so let's label that now. That's the missing side length. This is now 17. All right, and now we want to find all 3 trigonometric functions of theta. That means we're going to be finding sine of theta, cosine of theta, and tangent of theta. And these are just the ratios of the sides of a right triangle. So you need to put yourself standing on theta. So we stand here, Amber? Because the length can't be negative. You're right. Technically we would have to have plus or minus, but the length of a triangle cannot. So you are absolutely correct. You really should have plus or minus 17, but the negative 17 is nothing. Okay? All right. So now, sine is what over what? Opposite over hypotenuse. So if we're standing on theta, what's opposite? 15. What's the side opposite? 15. 15 over the hypotenuse, which is what? 17. Done. That is the side of theta. So if you on your calculator, if we found out what that angle was, and you press side of that angle, you would get the decimal to 15 over 7. All right, cosine theta. Adjacent over hypotenuse, which would be? Louder? Careful, I'm standing here. What's the side adjacent? 8 over hypotenuse, 17. All right, and tangent, opposite over adjacent, so that is what? 15 over 8, easy enough. Okay, so if you're asked to find the trig functions of theta, you're just setting up those ratio sides, just like you did in the activity at the beginning. All right. No, because it's asking you. Okay, so it's asking you for the tangent of theta. We don't know theta. If it asks you for the tangent of 30, then you would put that in your calculator, the tangent of 30 to get a number. But we don't know the angle, so we're just setting up the ratio. Okay? So you are not pressing a calculator button yet. All right, let's do it again. Find the missing side length and then the values of all the trig functions. So this time we're looking for what? Which side? C. So let's fill in everything that we know. We know A is 5, so we're doing 5 squared plus B squared equals 13 squared. C is always the hypotenuse. And A and B are interchangeable for the length. So I've got 25 plus C squared equals 169. Now what? Subtract 25. And I've got B squared equals 144. Take the square root of each side. And we'll get B equals plus or minus 12, but the negative doesn't make sense in the problem, so B equals 12. All right. Notice now my theta is up in the upper acute angle up here. So we still want sine of theta, cosine of theta, and tangent of theta. So, sine of theta, stand on the angle, what's opposite? What number? 12. Over hypotenuse? 6. And I will just see SOH, EAH, TOA written on every page of your test. Okay, cosine would be what? Adjacent, which is? 5/13. And tangent? Very nice. So the reason that we go out of order in the book at this point is that you all have ACC coming up, correct? Or PSAC. And those of you are an SAC. On all of those tests, right triangle trade will help you get through many problems. It's something we want to hit before you take that test. Usually it's at the end of the book. You don't get it to the end of the year. So we rearrange just so that you are a little more familiar with it before you go and take the test. All right, so we need to remember the way that the quadrants are numbered. Quadrant 1 is the top right. Then we go counterclockwise around to get the other quadrants. So this is quadrant 2, down here is quadrant 3, and over here is quadrant 4. And we need to remember the x's and y's signs in each of these. So in quadrant 1, they are both positive. And in quadrant 2, the x, we go negative in the x, positive in the y. So the x is negative, the y is positive. Quadrant 3, it's negative x, negative y. They're both negative. In quadrant 4, it's positive x, negative y. This becomes important on certain problems where they give you information about the sine or cosine in the quadrant that they're in. Should I hold up? No? All right, moving on. Okay. For example, problems like this. So it says the theta lies in quadrant 4. So here is my theta in quadrant 4. And the sine of theta is negative 2 over 5. You're being asked to find cosine theta and tangent theta. All right, so anytime you have to draw the right triangle, you draw it to the horizontal. You do not draw it to the vertical. So we draw theta here, there's our hypotenuse, and then we draw it up to the horizontal. Get this picture into your notes. First thing that I suggest you do, even though they have the negative type, the 2 on the top of the fraction, I would suggest you rewrite it as sine theta with the negative in front and then 2 over 5. Because we need to figure out which side we put the negative with. It does not have to go with the 2. And it depends on which ratio we're dealing with. So sine is what over what, Ms. Ogasawa? Opposite over hypotenuse. Yeah, we're going to just draw this right on our triangle. What you need to remember is that the hypotenuse is always positive. Because it's at an angle, so we can't really determine if we're going positive or negative. if I do this, so my x in this quadrant is that positive or negative? Positive, and my y should be negative. All right, so the hypotenuse needs to be positive, so I'm going to label the hypotenuse 5. All right, that means I have -2 on the top, and that is the opposite side. Does it make sense that that is a negative value? Yep, because we're going down. So we make the opposite side -2, and the hypotenuse positive 5. And now I need to find cosine and tangent. Well, to do that, I need to find this missing side. So we still need our Pythagorean theorem. And tell me what to plug in.
-2 squared plus b squared.
Yep, and I will tell you to be careful. Any negative value squared should come out positive. So put your -2 in parentheses, squared, plus b squared equals 5 squared. So -2 squared is what? 4, plus b squared equals 25. And now, what do we do? Subtract the 4. We have b squared equals 21. Get the square root of each side, and we get b equal to the square root of 21. And we'll leave it just like that. That one can't be reduced at all. Factors are not perfect for this. All right, so now we have all three sides. You can tell me what cosine is and tangent. And cosine of theta. Stand on theta. What will it be?
Square root 21 over 5.
Right. And tangent of theta. Very nice. Good. And that's it. Questions on this one? And sometimes give it in decimals, but it's much easier and cleaner to have fractions with a root instead of 5 over 4 point something. Kind of a strange fraction. It's easier to work with. Okay? All right. Let me try this one. Right, you're done? Theta lies in quadrant 2. So I've drawn my triangle. I'm going to label my theta here. You need to figure out where that negative goes, whether it's 5 or the 6. Which is 5 or the 6 to negative. So let's look at opposite. Opposite is here, that's going up, that's positive, so that should be 5. And look at our adjacent, we're going in the negative direction, so that's where the negative goes, -6. Can you just think about how do I get to that, how do I get to this point? Right here, I go -6 and up 5. Now, when you do the Pythagorean theorem part, I said to keep your negative in parentheses. Actually, when you're doing it, you can leave the negative off. Because when we square it, it becomes positive anyway. And if we're talking about the lengths, they're all positive. So it might be easier to just leave the negative off when you're finding your missing parts with the Pythagorean theorem. All right, if you look up, do you agree with my hypotenuse? Yes? All right, tell me what sine of theta would be then. I'm standing on theta. What's opposite?
Over 1.
Yes. sides?
Negative 6 over 34.
Okay, questions on these? Yeah.
So even when it's like the negative 5 is off, like when it's asking a question, like we just have to assume it's in front of the bracket. Yes.
They're not telling you it has to be with that line. Okay, so you don't need to look at your picture. Yep. All right, other questions with this? Yeah, Rachel?
How do you decide that
Because if you think about, if I were to draw these two lines to get to the hypotenuse edge right here, I have to go left 6. That's in the negative direction. And then up 5. Okay? So just start at the origin and say, am I going in the positive or negative direction? Other questions? Okay, so now this one gives you different pieces to be right. We only have one side. Which side is given? The hypotenuse. And which side are we trying to find? X. If this is the angle I'm talking about, it is opposite. Okay. And which trig function uses opposite and hypotenuse? Sin or sine, right. So we're dealing with sine. And we never write sine, cosine, or tangent without an angle. And our angle this time is what? 34. So we're doing sine of 34 degrees equals opposite, which is x, over hypotenuse, which is 13. And then we want to solve for x. So that this is there. Right? This is where we would press the sine button of 34 degrees to get a number. Do that now, please. Before you do that, make sure that you go to mode and make sure you're in degrees and not radians. Press mode and make sure degree is highlighted. A lot of my calculators may be in radians. All right. Once you do that, go back to your home screen and do sine of 34. And give me that decimal to 4 places. 5, 5, 9. What is it? 1? Does it round up to 2?
Yeah.
Okay. 5, 5, 9, 2 equals x over 13. How do I solve for x? Multiply both sides by 15. Cancel over here. And we get x equals what? 7.26. Get one more. 9. Fair enough. Okay. So now I know that this side is 7.269. That's the part we were looking for. Let's make sure they didn't ask for anything else. Find the missing side length using trig functions. Make sure you're in degrees. That's it. Okay. Questions on that one? Okay. All right. So these become very useful in application problems. How tall is the building? How tall is the tree? How far is it across the lake? All kinds of problems like that. So here, we want to know how far it is across the lake. So we're looking for length A. So stand yourself on the angle. What side am I looking for? Opposite, adjacent, or hypotenuse? I'm looking for opposite. What side am I given? Adjacent, which one uses opposite and adjacent? Tangent. So tangent of what? Thank you, 24 degrees. Is equal to our opposite, which is A, over our adjacent, which is 750. So same problem now, but you're pressing tan instead of sine. So do tan of 24 and multiply by 750 and tell me what we get. A equals 333. Point, give me 3 decimals. 921? So we're multiplying 750 on both sides. Solve for A. And multiplying by tan on 24. Are we okay with that? Any questions? All right. Move on. Okay. tall. Sorry, it's awfully tiny. I think I can make it much bigger. That's the whole thing. And it has a shadow 172 feet long. Find the angle of elevation of the sun to the nearest degree. So that's a term we need to be familiar with. All right, so we've got 125 feet tall and 172 down here. The angle of elevation is always measured from the horizontal. So that, sometimes that's not drawn in for you, and you have to figure out which one that is. So if we have something like this, that's the angle of elevation. And you need to be aware, also you may see the angle of depression. You have to draw in the horizontal of the chair. And this would be the angle of depression. All right, so if they gave you the angle of depression, you have to subtract that angle from what to get this angle in the triangle? 90. So theta would equal 90 minus the angle of depression. Okay, that's just for future problems. All right, so I'm standing on my angle here. What sides do I have? Opposite and adjacent, but I do not have the actual angle. So I'm going to write tangent, because that's what you opposite and adjacent, of theta is equal to 125 over 172. Does anybody remember how to find the angles in these triangles? Basically, we want to undo tangent. And to undo tangent is called the inverse tangent. So if you look at your calculator, to get inverse tangent, the second tangent button. So I always remember that if I see inverse tangent, or inverse sine, or inverse cosine, I read that as the angle whose sine, cosine, or tangent is. When you see tan inverse or sine inverse, you are finding an angle. The angle whose sine is, or cosine is, or tangent is. Okay? So, really what we're doing is we're taking the inverse tan on both sides. So just like algebra, when we do division to undo multiplication, we're doing inverse tan to undo tangent. And what you'll plug into your calculator, so these two undo each other, and we're left with theta, equals, and then on your calculator, do second tan, 125 over 172, and tell me what we get. 36.0075, right, we'll go with 008 degrees. So that is the angle of elevation. So anytime you're looking for an angle, we're doing second tan, or second sine, or second cosine. Any questions there? Kelly, you're all right? Yeah. Okay. I think that these are our last two. Yep, okay. Now, one thing that we'll start doing tomorrow is working with something called the unit circle. And what we do basically is we lay down some triangles on top of a special circle. And that circle has a radius of 1. Alright, so you see my circle here. You see my coordinate axes. And the radius is from here to here, correct? So the radius is 1, which means what part of the triangle is 1? The hypotenuse is 1. Okay. Then let's call this X and call this Y. unit circle. My theta is always drawn to the horizontal line, like here. And let's say I want to know what sine of theta is, with the way it's labeled now. What would sine of theta be? Opposite is what? Y over 1. So on the unit circle, the sine of the angle is the y value at that point. This point has an x on the y value. So a shortcut would be on the unit circle, if I ask for the sine of theta, you just look at the y. Because it is y over 1, because the radius is 1. All right, and what about cosine? X over 1. And again, on the unit circle, if I asked you for the cosine of 30 degrees, you would go to the point where that hits the circle, and you would look at the x value, and that would be the cosine of 30 degrees. So we would just look at that. What about tangent? Circle? Y over x. We would take the y value and divide by the x value to get the tangent. Those relationships where sine is y, cosine is x, and tangent is y over x, hold for all of our unit circle problems. All right, and let's see how we can do that. So, find the value of the three trig functions at the angle theta. Here's my theta. This is the unit circle again, so my hypotenuse is 1. And I gave you what this point is. This point is 5/13 for the x and negative 12/13 for the y. So, if you think about it, you could go over 5/13 and down 12/13, correct? To get to that point. But we can make this easier. If I ask for the sine of theta, we want to do the x coordinate or the y coordinate for sine. Which was it? Yep, so here's our x, here's our y. So the sine of theta is the y coordinate, and you can just get it from negative 12 over 13. Cosine theta? 5 over 13, it is the x value. Tangent theta, we put the y over the x, so it will be negative 12 over 13 over 5 over 13. And that is the same as negative 12 over 13 times what? 13 over 5. 13 cancel, and we're left with? Negative 12. Yep. We can leave it like that. So on the unit circle, it's even easier. Cosine, and the way I remember this is cosine starts with C, sine starts with X, C comes before S in the alphabet, X comes before Y in the alphabet, so cosine corresponds with X, sine corresponds with Y. Okay? All right. And homework. So you have a lot of time to get this homework done. What?
It's a little much older than that.
It's okay. We may take another day on it.